Hi friends, welcome back to this discussion on psychrometric chart. Psychrometric chart, as we discussed in the last lecture, is a beautiful representation of psychrometric properties, and it is a very useful chart for analyzing the air conditioning systems, for designing the air conditioning systems. So in this lecture, we would be discussing certain processes, certain important processes, and showing those processes on the psychrometric chart. And we would be using this background, that is the driver temperature being on the horizontal, the specific humidity being on the vertical, the variable temperatures slanting, the saturation curve, and the relative humidity lines as a curves. All this skeleton we would be using as a background for representing the various psychrometric processes on the psychrometric chart. For example, this process which you see being represented on the psychrometric chart is the sensible cooling. By sensible cooling, what we mean is that the specific humidity does not change, but the temperature drops down. Okay, so the process which you see over here is the temperature dropping down from T2 to T1. There is a drop in the drivable temperature. The drivable temperature reduces from T2 to T1, whereas the specific humidity remains constant. So obviously, when the specific humidity remains constant and the temperature changes, it would be a horizontal line away from the vertical during sensible cooling. During sensible heating, it would be just the opposite, in meaning that when it is sensible heating, it would again be a horizontal line, but the arrow direction would change. And why would that be? That is because the temperature would increase. So in the sensible cooling, the temperature remains, temperature drops down, but in a sensible heating, the temperature would increase. So this is the appropriate diagram where we see that the temperature is increasing and the specific humidity remains constant. So sensible cooling and sensible heating are denoted by horizontal lines on the psychrometric chart with the arrows indicating whether it is a sensible heating or sensible cooling. Now let us try out certain combinations of other psychrometric processes. For example, a very popular process which you see in the hot and humid climate for air conditioning, which is often employed, it is cooling and dehumidification. So what you see over here, just have a look at this figure and you'll understand that what is happening during the process 1 to 2. During the process 1 to 2, the temperature is decreasing. The temperature is decreasing from T1 to T2. Look at the direction of this. This is the direction of increasing temperature, and what we are having is the arrow towards away from the vertical, which means that the temperature, drivable temperature, is decreasing from T1 to T2 during this process. Hence it is a cooling process. Not only that, it is not simply a cooling process. You also find that something else is also decreasing. And what is that decreasing? You'll find that the specific humidity is being decreased from omega 1 to omega 2. So because the specific humidity, because the moisture content decreases, it is called as dehumidification. Dehumidification means decrease in the moisture content. So it is cooling and dehumidification. Process 1 to 2, there is a dehumidification from state 1 to state omega, and then there is a cooling from the state omega to state 2, right? This you need to understand very carefully, that the process is a slanting curve, and this slanting is in the direction of reducing of the temperature and reducing of the specific humidity. That is why it is a downwardly indicating arrow. It is downward, so the specific humidity is decreasing, and it is away from the vertical, so it is cooling. I hope that this process of cooling and dehumidification is understood. I mean to say, the representation of cooling and dehumidification on the psychrometric chart is clear to you. This is now also cooling, but with the difference. Look at this. This is cooling, meaning that the temperature is decreasing from T1 up to T2. Okay. But you also find that the specific humidity is increasing. So the temperature is decreasing, no doubt, but in this case the specific humidity is increasing. It means, for example, if you spray water, right, so there would be an increase in the specific humidity, and this process is called as humidification. So it is humidification because omega 1 increases to omega 2, and it is cooling because the temperature decreases from T1 to T2. So this is an interesting representation of a process called as cooling and humidification. It is the psychrometric process employed if you want to increase the humidity also along with the decrease in the temperature. Sensible heating we have already discussed, wherein we are not changing the specific humidity, but we are simply increasing the temperature. Heating and humidification. Look at this. You see that the temperature is increasing from this point to this point. Okay. So there is small mistake in this slide, but this would be T1 and this would be T2. So the temperature is increasing from T1 to T2. What happens to the specific humidity? The specific humidity also increases from omega 1 to omega 2. So please forgive this error which I have made while drawing this chart. Okay, so this has to be omega 1, this has to be omega 2. So what happens to the specific humidity? Specific humidity increases from omega 1 to omega 2. And what is the result? The result is it is a humidification. What happens to the temperature? The temperature increases from T1 to T2. And what is that? It is heating. So it is heating and humidification. So heating and humidification is employed in the places where the temperature is cool and the climate is dry. So we can employ a psychrometric process of heating and humidification to increase the temperature of the air as well as its humidity. The reverse is dehumidification employed along with heating. So again, here you see that what is happening. You see that the humidity, the specific humidity was omega 1 earlier. Now it has dropped down to omega 2, right? And the temperature, it was T1 earlier, it increases to T2. So the temperature increases from T1 to T2, specific humidity drops down from omega 1 to omega 2, and you can now guess that it is dehumidification plus heating. So it is heating and dehumidification. So it would be an employed in a climate which is cold, but it is also humid. Okay, so heating and dehumidification is a psychrometric process which involves heating as well as decrease in the specific humidity. So all these psychrometric processes, they are all fun, and these are fun in the sense that if you can appreciate those processes, then we can appreciate which psychrometric process has to be employed in which particular ambient condition, because we know that air conditioning is all about changing the conditions of moisture, whether we need to heat the air by employing sensible heating, whether we need to cool the air by employing sensible cooling, whether we need to increase the humidity also along with cooling, that is evaporative cooling, whether you need to heat the air but simultaneously decrease the humidity, which is heating and dehumidification. And if you want to cool the air and also remove the moisture, which is happening in the hot and humid climate, then it is cooling and dehumidification process. Okay, so all this makes a very interesting understanding. If you have understood the psychrometric processes, then you have understood how to represent those psychrometric processes in the real life air conditioning problems. Thank you very much. Bye for now.